Okay, an attorney claims that national data shows 25% or less of all U.S. lawyers advertise. Attorney believes lawyers in Manchester never advertised more than national average. A random sample of 200 lawyers in the city of Manchester showed that 63 had used some form of advertising. Using alpha at 5% is enough evidence to support the attorney's claim for Manchester, New Hampshire. All right, so this is another one sample proportion test. So we're going to use Z, right? So I want to go back to the previous page here and copy what I have and paste this here. Oops, Z. Okay, so as the proportion of lawyers that advertise. So still a portion of lawyers that advertise. Okay, so it's a one sample, right? Just New Hampshire, Manchester, and proportion obviously, and you're using Z. So we believe the proportion to be, oops, let's see here. We believe it to be 25 or less. So we're trying to prove that it's more than 25% essentially. That's the alternative. So do we have enough evidence essentially? Okay, step 2. Let's take step 2 here and put that here. Okay, so we have a sample of 200 people from New Hampshire, and 25% is P. So that would be 50, and then 200 times 75 would be 150. So both of those are more than 10, so that's fine. So this would be 25 here. All right, and we do our formula here if we want to. Equals the square root ratio, right? It's what? P times Q over N, right? In this case, it's 200, 0.25, and 0.75. And again, we're taking the population here for P and Q, not the sample. Because standard error for hypothesis testing is comparing to population. Okay, so there's step 2. So what are we doing? Can we do it, and what's the parameters? All right, step 3. Let's go back and copy here. Copy and paste. Okay, so we have 63 out of 200. That's going to be 0315. So we have 0315 minus the 25, and then 25, 75, and 200. So that's going to be a positive value this time. That'll be about 2.212289 . Okay, so that's our Z statistic basically. So let's go to here and do a little math in our spreadsheet here. So let's bring up our spreadsheet from before. Okay. And we're going to copy these. Copy and paste. Okay, and then we'll shift these to the right. Shift those to the right. Oops, I think I messed that up. There we go. Okay, so the Z-stat, we're going to put that in first, right? So that is 0.315 minus 0.25. That's the difference between sample, right, actual versus hypothetical population, divided by the square root of the 0.25 times 0.75 divided by the 200. Okay, so there's our Z stats. Now we got to figure out our area and our Z critical, basically. Okay, so let's go back to our picture here. Okay, so this is the proportion of 0.25, right? And this area over here, which we care about, is alpha of 0.05. That is this area here, correct? That is this area here. Okay, so this is my z critical value right here. So the question is z-stat. Is z-stat here or is z-stat here, basically? And notice we're on the right-hand side this time because it's a right-tailed test. So if we find enough evidence, we'll make it into this region. If we don't find enough evidence, we'll be in this region as far as our sample goes, right? So our sample is the 63 out of 200. So is that sample an ordinary sample in this range of what we would expect, or is it a special significant sample which will make it into this region, which means we will pass the critical value, the z asterisk essentially. Okay, so essentially to go from here to here, okay, that's going to be what, 95, right? Because this is 5% here. Okay, so normal dot inverse 0.95 comma 0 comma 1, which indicates that this stat value actually made it into that region because it's past the critical value. It's made it past it. So if I do my area, I need to do 1 minus the normal dot distribution of the z-stat, comma 0, comma 1, comma true. Okay, so I get 0.1016 as far as the area, right? Okay, so essentially, what do we have here? We have p equals 0.25, which is what we believe the population to be. Let's see if I can do this a little bit better. 0.25. That is our p, right? Which is z0. Correct? Okay, so over here we have z critical, which they usually put that as z asterisk as z critical, the critical value, which we actually it's the samples that are actually significant, right? And this is 0.05, so we did 0.95 to get there, right? As far as the z inverse goes. And the value that we got was 1.64, right? 1.64 ... Okay, so we got 2.12 for the other one, didn't we? Right, 2.12. So we actually made it to here, right? So this value right here is the z-stat. Z-stat, which is the 2.12 ... And that area we got was 0.16 ... area, correct? So we got 0.16. And notice that this area, right? I'm sorry, 0. I did that wrong. The area is 0.016, right? This is less than this. So if p is low, the null must go, correct? Okay, so let's go down to here. A little copy in here. I'm going to copy this so I can save a little bit of time. Copy. Oh no, we already did this, right? So this is 1 minus the z, right? So we got here, what did we get? We got 0.16881. Okay, 0.16881. That is our p-value, right? Because the area is the p-value. Area represents probability. All right, step 4. Step 4. Copy. Paste. Okay, so we have 0.16881, which means the p-value is less than the stated alpha. For the purposes of stats 1, we're just going to give you the alpha. Therefore, we should reject the null hypothesis. If p is low, the null must go, right? Okay, so our sample proportion is significant and likely to not occur, which means it's a significant sample. There is enough evidence, is not likely to occur. There's enough evidence to reject the null hypothesis. We did find significant evidence to say that Manchester lawyers advertise more than the national average. Okay, so that's our statement in context, basically. So we rejected this because we found significant evidence. We ended up in that shaded region, so wherefore we believe the null alternative hypothesis. So we found enough evidence, essentially, is the way that works.